So this is what you guys have to write in your exam when they ask about working of a cyclotron. So this is the diagram. So we have here the D's, right? This and this. Somewhere in the middle, right? This is the section, cross section of D. So somewhere over here, okay, we have something called as ion source or your charge source basically. This entire thing is in a vacuum, right? So this is airtight. Chamber. This is an oscillator. So it is oscillating between what? Between positive and negative. That is, it keeps switching the voltage. So this is your alternating, sorry, not oscillator, voltage. That's the one which is going to make this go positive and negative, so on and so forth. So this is called the window. This is where the particle will exit, right? And this is magnetic coil. Okay, so making it coil because we can make it north pole or the south pole. Does it make sense? So if it's north pole, then we have it going something like this. If it's south pole, it will go other way around, so on and so forth. So, but our window is fixed in one particular place. So it's ideal for the charge to go in this way only. Actually, it's not ideal, it is needed. So if we have negative charge, positive charge, we need to flip things around, right? Magnetic field has to flip around. So we need to have that flexibility. So it's just not a magnet, it's magnetic coil. Not magnetic coil, the coil which can electromagnet basically. Okay, so this is what you have to draw. And this is not for your exam, not for exam. It's only for your understanding. So this is the magnetic field line. And this is a cross section, say something like this, I cut across the D, and we are able to see this. So the charge is pushed to this point. Then from here it will go circular, small circle, bigger circle, bigger circle. And when it reaches the biggest possible circle, it will exit the window. This is basically the path of the charge particle. Okay, so basically, when I put the charge over here, so because of the push and the pull, say it will enter like this, and then actually magnetic field is there everywhere, so maybe something like that. Oh, it should be the other way around. See, if I don't go the right way, then it won't work. Something like this, and it exits. Again, you have a lot of loops that it will go, that it will take, and then it will exit. Okay, so let me put it in words now. The D's, this is how you need to write. The D's, the two semicircular container, D1 and D2 referred to as D's. So that's our D1 and D2. We'll label it off. Okay, so generally, yeah, vacuum chamber. So this has to be an airtight chamber. They're mounted inside a vacuum chamber between poles of two powerful electromagnet. Voltage source, the Ds are connected to a source of high frequency alternating voltage for a few hundred kilovolt. Source of charge particle, that is your ion source. Charge would be injected into D near the centers. Okay, exact place, to be honest, even I'm not very clear with. According to that, maybe this is the place. No, according to that statement. But few diagram shows this is the place. Now the working. And you guys can write about the magnet source, right? I forgot to write about magnet source. Magnet coil. The needed magnetic field is, you know, generated by this, so on and so forth. That is important. Actually, I missed it out. So a positive ion is released near the center of the cyclotron, so it's near only. The ion moves in a semicircle path between the two die. Okay. The uniform magnetic field bends the ion path into a circle. The applied voltage between its is adjusted to reverse polarity so that the ion completes a half circle. This reverse accelerates the ion, increasing its kinetic energy. This process repeats using the ion's path radius to grow. Okay, guys. So this is not for exam, not needed for exam. This is good enough. This main thing is good enough. So please add this point. If not, yeah, this is good enough for exams. Okay, let me write it off. Uniform magnetic field perpendicular to the plane of particles motion. It should be it produces a uniform from here till here. Okay, guys. So this is what you have to write about magnet coil. Okay, and the working.